Hi all, today I am going to go over an example from lesson 1 of module 1 of the EngageNY Algebra I curriculum. So let's go ahead and get started. Lesson 1 is all about graphs of piecewise linear functions, and we'll talk more about what a piecewise linear function is down here. But first, let's take a look at how they might be useful to us. So here we're looking at elevation versus time. So how high off the ground are you at what time? And then it's asking us, can we describe what the person might have been doing? So let's take a look at the graph. And then once we kind of analyze the graph, figure out what it's trying to tell us using different intervals or pieces of linear functions. So notice all of these are just different pieces of straight line linear functions. And what's helpful is the slope. So if we remember, slope is that rate of change. The slopes are telling us really how fast you are getting from one elevation to the next, and then the time, the x-axis, will tell you when you are doing that. So if we take a look, so elevation, it looks like we're starting here. Usually elevation is, it's just your height off of some surface. We can say it's the ground. So here we're starting at 0, and then we're going at a decent rate all the way up until we get to 10 feet. And then it looks like, and I'm gonna go ahead and mark when I get to, or when my different pieces start and end, and you'll see a little bit later why I'm doing that. So if we take a look at, it looks like, and I can estimate, but looks like I stop increasing at this specific speed at around three-ish minutes. So it's taken me some minutes. It took me 3 minutes to get 10 feet off the ground. And then if we look at our next piece, this is a piece with a slope of 0. So basically what that's telling us is I stayed at 10 feet, or this person stayed at 10 feet for probably a minute, because it looks like this next piece ends about 4-ish, right? So it took us 3 minutes to get 10 feet off the ground. It took us 1 minute or about 1 minute, that we stayed at 10 feet. And then notice this slope is quite a bit steeper than our original ascending slope. So we ascended, looks like we went up to 15 feet. So we went up about 5 more feet. But notice this slope is much steeper, and we know that a steeper slope means you're going faster. So we actually increased 5 feet. Let's kind of see where this matches on the x-axis. So if halfway is 5, we'd say that's maybe 4.5 minutes there. So it took us just about half a minute to increase 5 feet. So we're going quite a bit faster than we were originally. And then notice we've got another piece with a slope of 0, meaning something is causing us, and we can maybe attach a story to this once we're done analyzing it, but for something has stopped us at 15 feet, time is still going forward, so we are not ascending or descending for about maybe 1.5 minutes, from 4.5 to 6 minutes is what it looks like. And again, I'm estimating, and that's okay. Okay, so maybe from 4.5 to maybe just under 6 minutes, our slope is 0. We're staying at that 15 feet. And then it looks like we're really quickly going back very close to the ground. We're not going directly to the ground. That's not until 10 minutes, but we're going pretty quickly. Notice that slope is quite steep. I'll estimate that at about 7 minutes. That's in between 6 and 8. So it took us about a minute to quickly go back down to the ground. And then notice these pieces, we've got our constant rate, slope of 0 for another minute, and then it looks like we're descending back down to 0. So after 10 minutes, we are right back where we started from. So in maybe attaching a story to this, so we're talking about minutes. Maybe let's say we are trying to get to maybe a specific building that is maybe at the top of a big hill, right? So maybe the building is here. We park down at the parking lot. So we start maybe slowly walking up a hill, and it took us 3 minutes to walk to the top of the hill. Maybe it flattens out a little bit, or maybe there's a little landing, and then maybe we've reached some stairs, right? So we're able to elevate a little bit quicker with stairs rather than just walking up a gradual hill. So we're going a little faster with the stairs. We are at 15 feet off the ground for just a minute and a half, and then maybe let's say we forgot something back at our car at the parking lot. So we forgot something. So I'm actually really quickly gonna go down the stairs and forget the landing, right? Because I'm going at a really quick pace down the stairs, then I'm gonna maybe start going down the hill a little quicker. And maybe this is a little curb. So notice this is about 1 foot off the ground. I hit the curb and then drop back down into the parking lot, right? So again, this is just kind of an estimated story about elevation over time. I'd love to hear some other examples if you have them. But basically, piecewise linear functions are really helpful in telling us, what is happening when, in situations like elevation over time, that it might be helpful to either, maybe they're exactly aligned to specific linear functions, or maybe this is just our best estimate as to how quickly we are, in this case, elevating off the ground. So overall, why am I calling this a piecewise defined linear function? I feel it's pretty, piecewise kind of explains, you're gonna have a bunch of different pieces. Not all piecewise defined functions are linear, but in our case for this lesson 1, that's really all we're looking at, is we have non-overlapping intervals. So notice what that means is whether your pieces are touching end to end, or like on this other example where maybe they're still linear functions, they may not just be, they may not be touching end to end, and that's okay. But notice they're not overlapping because of course they're functions, which means each x value only gets one y value. Each x value gets one y value. And it's the union or the collection of all of the intervals that are defined by different functions on each interval. So, and I use that word a few times as well. What's an interval, right? So an interval, we usually use x values to describe what an interval is. And basically those x values, think about, we measured time right here. And even if you're measuring something a little different, basically the x values tell you when were you doing something that is being measured on the y-axis. So the x values tell me when different things are happening. So let's look at this example right here. So if I think about, okay, I'm increasing and then I decrease and then I'm going at a constant rate, okay? So when am I increasing? Well, I'm increasing. It looks like I'm starting at 0 and I'm ending at about 2. So there's several ways to write intervals, but a lot of the times, in this case, really, I'm just asking you to identify them. So from 0 to 2, and this is just this example, from 0 to 2, I'm increasing. That's my first interval. When am I decreasing? How about, so I'm decreasing at 2, that's when I start decreasing, because I switched around really quickly. So I start decreasing at 2, when do I stop decreasing? At about 5. So from 2 to 5, I'm decreasing. And then my next interval, notice it's got my little arrow, so we can assume that this constant rate's gonna continue on. And of course we can't draw a graph forever, but this arrow tells me that I'm gonna continue at a constant rate. So from 5 to, you can say infinity, you can say onward, either way. Continuing on, I will be going at a constant rate. Okay, so these are just some examples of when when you might use intervals to start describing things, and this is going to become a lot more common as we work with graphs, not only with linear functions, but any type of functions. So we've got increasing, decreasing constant. Those are helpful to use. Intervals are helpful to describe when you're doing certain things. And of course, linear piecewise functions, which is what this lesson is all about, are really helpful in telling different types of stories when you want to explain maybe how something is changing over time or in a similar situation. So thanks so much for watching. Again, this was EngageNY Algebra I Curriculum, Lesson 1, Module 1.